Yeah.
Hello and welcome to Martin Maths. Today we will be discussing the different sets of numbers. A set is any well-defined collection of items, and the members of a set are called its elements. For example, let's have set A, and this is all about even numbers. So the elements of a set are put in curly brackets. So that, and since they're even numbers, that would be 2, 4, 6, 8, etc., all the way up to positive infinity. So that is the set of even numbers. But these aren't the only numbers in maths, of course. All the numbers in maths can be placed into different sets. The first set you're likely to come across is the set of natural numbers. This is represented with a double-lined n because they wanted to differentiate it from a regular n. And this is all the set of counting numbers, or natural numbers is the official term. These are all the numbers used to count daily objects. Now, there's actually a debate on whether 0 is an element of n, but in the IB syllabus it is, so would count it as an element. And the natural numbers, the set of natural numbers involves 0, 1, 2, 3, all the way up to positive infinity. So I'll just put that here, so you're aware that 0 may or may not be an element of n. This fancy E notation here just means is an element of. The next set you're likely to come across is the set of integers. These are all whole numbers. So that means these are negative whole numbers, positive whole numbers, and 0. So that is from negative infinity, 0, up to positive infinity. Next is the set of rational numbers. This set involves all numbers that can be written as fractions with integer denominator and numerator. So that is, in official language, P over Q, where P, Q are elements of Z, and Q is not equal to 0 because you cannot divide by 0. For example, if we had the number 9 over 10, that's 0.9, and it can be written as 9 over 10 as well. So 9 is an integer, 10 is an integer, and 9 and 10 is not equal to 0. So therefore, these three dots mean therefore 0.9 is an element of rational numbers. But a lot of numbers can be considered rational that at first you may not think of. For example, all natural numbers are rational because they can be written with the denominator 1. So 8 can be written as 8 over 1, and that makes it rational. Even negative numbers can be written as negative 1 over 1, etc., etc. But there's a special case where there are recurring numbers. So let's have a number called x equal to 0.81 recurring. That means 0.818181 up to infinity. And multiply that by 100, so that's 100x equals 81.81. Now notice how the part of the number after the decimal is the same. So if you subtract x from 100x, you get 99x on this side, and you get 81, because these two parts cancel. Then dividing both sides by 81, you get x equals 81 over 99. Now 81 is an element of z, 99 is an element of z, and 99 is not equal to 0. Therefore, x is an element of q. There are more sets, including the set of irrational numbers. This is shown with q dash. The dash is read as is a complement of, which means everything outside of q. Irrational numbers have three features. They are non-terminating, which means they never finish. Just like 0.81 never finished. It just went on for infinity. And then there are also non-recurring, which means that decimals don't show any patterns. A common example of this is pi. And there are also not fractions. They cannot be written as fractions with integer numerator and denominator. So that could be root 2, or even another number, if you have not come across it yet, you're likely to soon, e. Finally is the last set of numbers known as real numbers. These are all the numbers used in daily lives, and that's shown with the letter R, double-lined. R is defined as the union of Q and Q dash, and union just means combining the elements of both sets. So that's all rationals and all irrationals put together gets you real numbers. Now there are other types of numbers like complex numbers. These numbers aren't used in daily life, they're completely imaginary. For example, the root of -1, which is written as I, because no number in the world multiplied by itself can get you a negative number. So therefore this is an imaginary number. But how do these sets of numbers relate to each other? Well, that's shown by this Venn diagram right here. R is everything, and we have complex numbers on the outside because they aren't real numbers, they're imaginary. And inside we have two divisions. There's Q dash, which is the space outside of the bigger circle. Inside the bigger circle are all rationals. And inside the rationals are all integers, because all integers are rational numbers, since they can be written with the denominator 1, as we saw before. Inside the integers, there are the natural numbers. All natural numbers are integers because they are whole numbers. And this is how all the different sets of numbers relate together. Formally, it's written like that, which means natural numbers are the subset of integers, which are a further subset of rationals, which are a further subset of real numbers. Thank you for watching this video, and don't forget to like, subscribe, and share.